Hey guys, how's it going? We don't have anybody in here yet, but woo, don't knock over the monster. Love this stuff. That's the orange dreamsicle. Fantastic flavor. Um, let's see if I can link up my computer here too, so that I can watch. There we go. That way I can see chats. Computer set up. So, all right, today we are here to talk about motor towers. This one is from the Warhead 20K motor. The Warhead 20K motor. I bought the 20K basics for my gun, my gearbox that I'm working on, a customer's gun that I'm working on, and a couple other things. So I have the basics because I'm more concerned about trigger response than rate of fire. So these both have, well, this one is a Siege Tech 20-to-1 ratio, or 20-to-1 ratio DSG set that I'm building. This one has Rocket 12-to-1 gears. So we'll be doing talk on those. So what I found when doing these, and this is pretty common across most brands, is the motor towers aren't sized correctly for gearbox shells. And they do this to make space, to try and make the motor towers the most compatible across the most amount of gearboxes. The problem with that is they make them so undersized that it affects your shimming. And when it affects your shimming, it's going to throw everything off. It's going to cause more wear. It's going to cause the sound to go to crap. I mean, there's a few things that affect shimming. Like everybody goes, it's perfectly shimmed. Everything I have is perfectly shimmed. And then you do it and it still sounds like shit. And the problem with that is one of the big contributors to that is this. Now there's another one that I'll get to when I start talking about the shimming. There's another issue, and I may try and do another live stream so I can actually demonstrate that issue. And I don't know if anybody or how many people are actually aware of that issue, which is the bevel gear on most of them, all our bevel gears and our what's it called, our pinion gears, most of them are cast, and in that casting you can have that little bit of off. I'm sure there are some techs out there that have watched it and they've spun a bevel inside and you can actually see just this tiny little wiggle up and down of your gear. Now that also happens when you have it together and you have a tiny little wobble with your pinion gear and a tiny little wobble with your bevel gear. And you know what I mean? You could be shimmed perfectly in one rotation or one spot of that rotation, and then it's off in the other part of it. So unless everything was CNC machined to fit the tolerances together for the gear set, everything from the sector gear to the pinion gear, then you would have something that would work a little bit better together. But most stuff doesn't do that. So one of the things that I've done, and I've shown it in several posts on my Instagram on pictures and stuff like that, is is sorry about that, dogs. Is the amount of play that is inside the gearbox shell when the motor tower is in there. Like, and just to show you for measurements, hold on, I'm going to switch up cameras here so I can show you an example and why this is such a huge issue to me. We are going to change position of the camera. I really wish I had a better camera setup, but I don't. So you work with what you got, right? All right, so we rotate the cameras. Now these are some of the tools I use. I prefer to use name brand stuff if I have it. So Mitutoyo or Starrett, Brown and Sharp is good stuff. I don't actually know who the OEM of the Blue Point stuff is. I know the parent company is Snap-on for Blue Point, but I don't know who actually OEMs their micrometers and stuff like that. This is the only metric micrometer I have. Most of the stuff I have is actually imperial measurements. So most of the time, most of the measurements that I do are imperial. Sorry for you metric guys, which sometimes actually can make it a pain in the ass for airsoft stuff, because airsoft stuff is all metric. So we can't always see what we have going on, right? So one of the things that I've noticed, and we will go ahead and use the Mitutoyo Absolute Digimatic here, because I can do metric on it. We'll clean the blades so that we don't have any material on them. Come down, we are at 0. I am in metric, of course. So first thing is I do believe this is an old rocket motor tower. We got 901 millimeters. 901, 9. So that's small. The warhead ones that just came off these motors, 899, 898, 898. That could, just be on how I'm pushing on it a little bit. This is a newer rocket motor. .944. So the size has increased. The size has increased from the, what's it called? From the 9. Oh. And this is an old SHS motor, but I think the bearing spring guide here is actually from an old classic Army motor, because this is brass. And on that one, we're at a 939, 939. Now the actual size that fits in this Lonex gearbox, which is a popular gearbox for replacing. If you're not going with the CNC machine gearbox like the Eon or the Mancraft or the Retro Arms, which is the most popular one right now, or it's one of the longest ones that's been around. So this is the one that actually fits in the Retro Arms gearbox, or sorry, the Lonex gearbox. We're at 10 millimeters. So at 10 millimeters, we have a 0.5 millimeter worth of difference in between the stock ones that have come out and the new ones, or sorry, in between the stock ones that come out and the actual hole in the gearbox. So, so for the Eon gearbox, where's that motor? There it is. So the Eon gearbox, it measured out at 9.78 millimeters. So we still have a 1/4 millimeter, 0.2 millimeter, 0.25 millimeter, difference. And that kind of a difference actually leads to play. Let me go ahead and open this up real quick. What's up, Prime Tech? As you can see, I use all Torx screws in mine. Mine are all stainless Torx. This is another product that I plan on launching here soon. I've sent some testers out to some people. Everybody seems to like them so far. I just actually have to work on the company that is going to manufacture them. I've gotten samples from several companies. Some of them I liked, some of them I didn't like. So it's all in making the determination of who's actually going to produce the best quality product, and I can get it to you guys at an affordable price. So in here, we're going to show you. All right, and just so you guys can see, those are my screws. And this is my current screwdriver I really like using. It's a little Husky. Comes with a whole bunch of bits inside of there. You can buy other bits to it that'll match that size or match the sizes and stuff, so I really like it. All right, so let's get this, see if I can get this apart without throwing all my shimming off. Look, it's a dry gearbox, so none of the shims actually stuck. And we'll get rid of the compression system because we do not need that right now. And I don't need the bevel gear. I don't need the shims on the bevel gear. So those shims will go, oh, there's the other one. Those shims will go where they are. So, the gate shell seems to be really nice so far. I actually haven't run it yet, but as far as tolerances go, the tolerances seem really nice. So I haven't had any issues with the tolerances yet. We will see when I actually put a motor grip on it and run it and see how it fits inside of a shell. It has some cool, neat features. Maybe I'll talk about those in a little bit as well. Let's get some of these tools out of the way. Tools are just up here so I can show you guys the stuff that I'm working with. You know, none of the tools I use are Harbor Freight Chinese tools. They're all, as far as the measurement tools go anyways, they're all, you know, high-end stuff. So, yeah, see, this is a motor that I built. As you can see, that has an O-type armature inside of that for this SHS motor. It has an O-type armature, which the SHS motors didn't come with. So that's why I'm pretty sure this is an old classic Army. Yes, it is definitely correctly deburred. Like, the machining quality on the gate shell is really, really nice. Now I'm still working on tolerances, but as far as the machining and stuff, I really, really like it. Like, the quality of the machining is cool. None of these companies have gotten rid of the tool marks, although tool marks for what we do really aren't that big of a deal because the tool marks aren't going to affect our tolerances and stuff like that. You know what I mean? So we have our bushings glued in, we have all of that stuff. So, but one of the really big reasons why this subject is so important, why the motor tower fitment is so important, is because these two gears, when they turn, especially if you're using like a DSG set where you're using a heavier spring, or 12-to-1 sets like I'm using in this gearbox, there's a lot of torque that gets applied. So you need, there's a lot of torque that gets applied, especially with these motors, and brushless, I would assume brushless motors too, because they got a lot of nice torque to them, where you're going to have flex. Now, this is a long distance right here. This distance right here is more than you would need. Well, not more than you need, obviously, because it's got to fit in the gearbox. But it's more than you would want to have a lack of support. underneath it. So because these gears, they have opposing forces. So when the gear turns this way and your bevel gear turns this way, it's pushing the teeth against each other, and this pinion actually pushes out and the bevel gear pushes back against the gearbox. Now, since you've shimmed the bevel gear to the pinion gear, it's locked solid against the back of the gearbox. So the bevel gear is not going to move. It's flush against the back of the gearbox and it's not going anywhere. It's also one of the reasons why when people use bearings inside of gearboxes, or at least knowledgeable techs use bearings inside of gearboxes, this side of the bevel gear and the bottom side of the spur gear, they take a lot of axial force. So instead of, your radial force is in line with the gear. So radial force would be pushing it this way, and axial force is pushing it this way. So when you have that axial force, it's forcing the gear back against the bushing. Well, or back against the bushing or the gearbox shell or whatever it is. But you have that sat flush there against it. It's shimmed up. It's not going to move. As soon as the gear kicks, it starts turning, and the force that's pushing against it pushes it this way. But if you have 20 thou, 30 thou, 0.5 millimeters worth of gap in between this motor tower and the gearbox shell, all that opposing force, all of that torque is going to start pushing this that way. It's going to wedge it this direction, which one is going to throw off your shimming, and you're going to have, what's up, Danny? It's going to throw off your shimming, and it's going to push everything this way. And that's why, like on a lot of these, you'll actually see when you look at some of your gears, when you pull them out, you see like the tip right here that's actually worn. There's not a whole lot of wear on this tip, but you will always see wear on this tip down here on the bottom. You know what I mean? You'll always see the shiny, and it'll always look like it's sharp right here. Nia, tell Liz that the hole puncher is in the office with all the rest of the bushing stuff. Okay. When you go back out. All right. So you'll have the wear on this tip right here instead of this up here, and that's because it's pushing outwards. And as it pushes outwards, and especially if you have like a loose motor grip where the motor will actually just kind of sit that way, it'll just sit a little crooked already. And that's why, like, you think you have it shimmed perfectly. You're like, it's shimmed great, it's shimmed great. And then you have a motor tower that's, this far undersized. And then as it fires, it tilts, it pushes the pinion this way. It was one of the things that I noticed. I produced motors for a little bit. I started making some motors for a little bit. I got a bunch of samples, but I didn't like the quality of stuff that they were doing. And then what's it called? Because they made them just like the ASG CNC motors. So it had the CNC bottom, it had the CNC and the CNC top with the housing that was glued together, or with the housing that was together, and everything was like glued or screwed into place. So the what's it called? So I actually watched this happen because they didn't have any support up here. And it was one of the first reasons why I started noticing that there was an issue with this, and the amount of torque that's applied with some of these motors, because they didn't have any bearing support up here. So it flexed the shaft over and actually caused wear right inside here. The pinion would contact the inside piece because it didn't have this gap here. It actually went all the way up to the bottom of the pinion gear. And so it pushed it, and it actually caused wear on the edge of this piece. You could actually see where it was worn right there, which I was like, okay, that's not a good deal. It didn't destroy the gears, but there was a definite change in the sound when it was being used. You know what I mean? There was a definite change in the sound when it was being used. and you could see how sharp the tips of the gear were. I don't have that right now, and I don't have anybody that I can actually tell to go grab it that would know what they're looking for. I should have grabbed that this morning, because that would have been a good example. But that's what happens is you have, when these gears turn, there's opposing forces. So they're going to push this apart from each other, and it's going to flex, and that's going to throw your shimming off, and it's going to cause wear. So that's why motor tower size is important. You know, with this inside this gearbox, it has gone from 20 thou or 30 thou a play to like 2/1000ths of an inch inside of here. Like this piece, well, I won't do it on this one because you won't be able to see it very well because my gearbox shell's apart. This one, like with the original, where it is, there's the Warhead one. This is the Warhead one. With the original piece in there, like you can see that gap. That is a huge, that's a huge gap. Like that's all kinds of room for your stuff to float around inside there. If your gears were floating around with that much space inside of your gearbox shell, you know what I mean? And you were a good tech, you'd be like, what the hell is wrong with this thing? Like if you got a gearbox shell and that was like that, you'd be like, that's crap. But not as many people question the fitment of this. You know what I mean? Whereas this, I slide that in there. Oh, come on. She's tight. But that's in there. Like that's, that gear, when you run this motor, is not going to move. That is just going to fit. And I'm supported all the way up to the motor, all the way up to the belt or to the pinion gear. It's supported all the way up to the pinion gear. So it's not, there's not going to be any flex in this part. So whatever I set this shimming at inside the gearbox, whatever this shimming is on the bevel, that's what it's going to stay. It doesn't matter how much torque is applied. It doesn't matter how much of anything. As long as this bearing is in one piece, that is going to stay where it is. And it's this, that bearing is going to take all of the axial load inside of it, because to that bearing, it's a radial load now. And there's no flex. You know what I mean? The shaft isn't going to move. The shaft is locked in the gearbox, and it's not going to go anywhere. Danny doesn't want to make motors. So, but I mean, that's part of my stuff right there. That's my main thing for motor towers. You know what I mean? That's the main thing for motor towers. It has to fit correctly, because if it doesn't fit correctly, it's not going to work. You know what I mean? Now, I could start making these and just make them out and produce them. 385 thou, 380 thousandths, would put it real close tolerances, and it would fit most gearboxes. Honestly, Tinleys are a little bit overpriced. They're cool for what you get, but they're overpriced for what it is. Yeah. SJAC, correct. There is a large bunch of sizes between shells. And what sucks about that is you don't need that much. I mean, this is not like a proprietary set piece. That hole inside of the gearbox shell is not proprietary. You know what I mean? It's not like, oh, we've optimized this size of gear measurement, or we've optimized, you know, these piston rails. You know what I mean? There's certain things, and that's one of the things that I want to push towards, is a standardization in airsoft. Like in the firearms industry, there's a standardization. You know that it doesn't really matter a lot what brand makes certain stuff. Like the best thing I can say is the AR-15. If you know you're getting an AR-15, you can buy pretty much any part out there and everything's almost drop in because there's standardization of those sizes. And the whole industry understands that standardization in between certain sizings is important. The problem is the airsoft community, the airsoft manufacturing community as a whole does not understand this yet. They don't understand the importance of standardization for certain measurements. You know what I mean? Like piston sizing. You could make all the piston sizes the same size. You could make piston sizes the same size. You can make the holes in these gearbox shells all the same size. You can make tappet sizing. That can all be made pretty much the same size. Nozzle sizing could all be made the same size. You know what I mean? But everybody has, you know, their own specific thing. Oh, I've made it this much better because I've changed this. I've made it this much better because I've changed this. But in reality, you're not making it better. All you are actually doing is making your stuff proprietary with no real benefit. And that's the problem with the community, with the firearms, or not with the firearms, but with the airsoft manufacturing community, is they don't understand the importance of standardizing some of these measurements. And if they did, we could make as aftermarket communities and stuff like that, and other aftermarket parts manufacturers, you could make so much stuff better without having to have an issue. So, I mean, that's one of the things I would love to push for, but we need more people. So, but, you know, if we could get companies like Warhead on board to do stuff, or T238, if we could get them, what's it called, on board, you know, if we get enough people that can talk to them and be like, look, these motor towers need to be bigger. This is the common size for stuff. These motor towers need to be bigger. And then they could start manufacturing and make the tolerances tighter. So there's less of an issue. Now, it might not completely solve the entire thing, but it could solve a big chunk of it. Now, people that I would want to give, that I would really, really want to talk to, something like Real Deal Airsoft. He's having motors made to his specifications. This is something that he could change on his motors. Same with Paragon Armory. He's manufacturing, he's having motors manufactured to his own specs. So this is something that he can change. He can make these motor towers bigger and tell the companies, be like, look, I'm ordering these motors. This is the size motor tower I want on these motors. And he could get it at a 385 thou, and it would make it fit, you know, the gate gearboxes, the retro arms gearboxes, the fucking, you know, a bunch of the different gearboxes. These companies here are who I would push to first, because once they see that once the bigger companies see that enough of these motors are getting made with these larger motor towers, then they will look at it and go, okay, there's enough customers that are requesting our motor towers to be bigger. We should start making these bigger as a standard feature instead of asking them to be done as a custom job, you know. And sure, I could make motor towers. I could make a shitload of motor towers and just produce them out and push them out and make a good amount of money off of them, pushing them as another product like that. But I would rather see companies like Real Deal, companies like Paragon, T238, you know, they're still small enough that they take advice from techs that they consider reputable. I'm going to be talking to my rep over at SHS, and I'm going to be talking to my rep over at Rocket Airsoft and sending them this video. So hopefully they'll see the importance of doing this. And if they can see the importance of doing this, then maybe soon we'll start seeing motors from those companies as well, pushing larger motor towers to be able to fit the gearboxes. Now, to do this, it would be great. I'd love to have, what's it called? I'd love to have information from the community. We have enough people out there with decent tools. I mean, even these, if they are worked right, can give you really, really good, you know, could be really, really good to have. Just measure it out. Measure what your hole is. And the correct measurement, I've had a few people, they sent me the measurements and they measured them this way. Unfortunately, this isn't the correct way to measure it, because if you look at that, I'm at a 1024, 1026 right there. You know what I mean? But when you measure it this way, I'm at a 10. So you want the smaller diameter. You want to know what the smallest diameter is, it because if you know the biggest diameter, it's not going to matter, because if you make a part that's that big, try and fit it in a hole that's that big, it's not going to fit. You know what I mean? Or you're going to damage it. So the correct measurement, if we want to do this, and I'll build a spreadsheet. If I get people that'll send me this information, I will build a spreadsheet, because one, it'll help me. Two, it'll help me push this to manufacturers. You know what I mean? So we can get these measurements right here and then send them to the manufacturers. And maybe we can get these manufacturers be like, if we can get what's the most common size or close to what the most common size is, where maybe you have a 0.1 difference, you know what I mean? 0.1, 0.1, 0.5 difference in between, you know, this gearbox and this gearbox, or in between that, you know, so we can get the one that's made for the smallest sizing. And when you put it in one that has a bigger size, if you only have a 0.1 difference, it's not nearly as bad as this monster 0.5 millimeter gap that's inside there. Danny, it's really not. It's not. Fabbing those kind of tolerances is really not that. Most of these companies advertise that they can hold a 0.01 or a 0.02 tolerance. You know what I mean? Which is 1.25 thousandths of an inch. A 0.25 is, it's small. It's only a couple thou. You know what I mean? And if you tell a company, if you can get me within a 0.05 of that sizing, they'll tell you they can do that all day long, no problem. So getting it down to a 0.1 or a 0.05 tolerance is not that hard at all. My bushings are held to, I think, a 0.0125 millimeter tolerance. My bushings are held to within 1,000th of an inch. It's not really that big of an issue. You know what I mean? If you get a company that's making quality CNC machine parts, it's not that hard to get down to 0.01, 0.02 millimeter. It really isn't. You know, any company that's going to do that is going to be able to tell you this is what we can do. So yeah, it's not an issue of whether the company can do it. It's an issue of whether we can convince the companies it's worth changing the design, and that's the biggest issue. And the only way to tell the companies that it is worth changing that design is by smaller companies starting to make these parts, starting to ask, hey, this is the size I want this piece. This is the size I want that piece. And once they start seeing that people really want that size piece, they'll start making it, because they know that's their moneymaker. Because they're like, okay, I get, you know, Paragon and FLTAIRSOFT, and they're ordering 1,000 of these motors in this size, and they're selling the shit out of them. And our motors aren't selling, you know, the motors for the other companies aren't selling as much because they don't have the correct sizing. So let's change it to this size so that it standardizes it throughout the manufacturing community. Right. And getting the bigger companies to start thinking about it. It starts with the smaller companies, though, because the bigger companies will follow the smaller companies. Oh, the SJSC. You want to know what the bearing size for the tower, the bearings that I manufacture, the ones that I made, or the ones that are in the current bearing towers? Because the ones that I have in mine are larger than these ones. And if you're interested in the ones that I put in mine, this is actually what I used in mine. 1/8 inch by 5/16 by 9/64. So I ordered mine from Fast Eddie Bearings. They're not super expensive. This set it's like $12 for 10 bearings. They're ABEC 3. They have a ceramic set that's actually bigger, or not, sorry, not bigger. They make a ceramics version of this size. They're like 4 times more expensive because they're like $41, $42 for a 10 pack. And all they're a hybrid ceramic, so they have the ceramic balls inside of them. And I think those might be an ABEC 5. But an ABEC 3, if you know your ABEC ratings, or you can just research your ABEC ratings, it'll tell you what you need to know. And it's that your ABEC rating is mostly on some of the tolerances and some of the measurements that you have to do on some stuff. So that's my stuff. You know what I mean? That's what I ordered. I'm gonna give these a try. The old stuff I had was RC car. I got them from an old RC car shop, like way back in the day. So, but yeah, I think these are rated to 50, 60,000, 40, 50, 60,000 RPMs. I told him that most of the motors that we run this stuff in is going to be in between 30 and 45K. And he was, or in between 20 and 45K. And they said that these will handle it no problem. So, and that's the important thing is making sure that it's going to handle the RPMs on everything that's going on. So that's what I have for motor towers. I was planning on doing this for like an hour, so I do have a little bit more time. So one of the things that I'm going to go ahead and touch on is shimming then. That's one of the things I want to go ahead and touch on is shimming. So hold on one second. Oh, you know what? Actually, guys, hold for 1 second. I'm going to go grab one of my old motors so I can actually show you the flex that I was talking about on this motor tower. It'll take me like a minute. All right, guys, I'm back. All right, so I found an old ASG motor that I tore apart. This was before they had the motor towers, or before they had the bearing support in the motor towers. But you can see Look at that. You can actually see the flex that happened to the motor shaft. And that flex caused this wear. And you can actually see how far it actually pushed it. You know what I mean? That whole spot is worn out. And that's how far, when it flexed, it would push that, because you have this huge hole and there was no support inside of there. So when the motor fired up, the opposing force in between your pinion gear and your bevel gear just pushed this shaft outwards. It just said whoop and flexed it, and it caused it to wear there. Now, which one of these motors, because I have a bunch of these motors, and these are ones that I actually have made. There's several of these that I've never even used because of this issue. I spent thousands of dollars on motors and never used them. All right, here it is. This is the one that I use the most. Yeah, there was three of them in here that I used. But this is one of the ones that I used the most. Let's see if we can get you a good look at it. Yeah, see, look. You can actually see, same thing. There's no bearing support inside this motor tower. And it pushed it, and it wore that much. It sat in just like this. And when that motor fired up, it pushed this pinion gear all the way over. And that was one of the times that I started to realize that this was an issue. Like, you can see inside of there how far, because this pinion gear is actually pushed down inside of this motor tower. You know, because it was CNC machined. It was pushed down inside this motor tower, and you can see where it is actually grooved out the aluminum underneath. And that just, you know, that shows that there's all of this flex inside of here when this thing fires up. So, you know, that's an issue there. Now this is with these magnets are strong. Huge magnets in these things. So that was the big issue right there. You know what I mean? That was one of the things that I always saw, and I was like, oh, now you would almost want to be like, well, you know, these motor towers have a bearing inside of them, and it has the support, so it's not going to do that. But the problem with that is if you have your bearing support inside of here, but like this one's a double bearing, so it just rides on the motor shaft. So if the motor shaft gets that flex and gets pushed, this is going to push with it, and it's going to push until it finds something to stop itself on. And what it's going to stop itself on is the gearbox shell. It's going to go dink, 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 dink inside of there. So every time you fire it up, it goes back and kicks to the other side until it stops. You know, yes, it's going to be more on stuff like this that just had this huge open hole in the bottom and no bearing support on top, and it would push it over. You know what I mean? And this design with the bearing support, this design actually helps a little bit, because this is all CNC machined one piece. You know what I mean? And as long as your glue is holding here, then this design isn't super bad, because it's going to push over. But anything that has the floating motor tower, like this one does, as soon as that kicks over, it's going to push, because this isn't connected to the motor housing. This isn't connected to the actual shell of the motor, whereas this piece would be connected to the shell of the motor because it's glued into place. So this one, if it had the bearing support, probably wouldn't have caused this wear, because this whole tower piece is machined as part of the motor, whereas this is a separate part from the motor. So this piece is going to flex over. Now the ASG ones that are CNC machined like this, that the new ones that actually have the motor support tower, this isn't as big of a deal. I would still say that these need to be made bigger. You know what I mean? They need to be made bigger to fit the gearbox, because it's just going to help support the whole system that much more.
But the CNC machined one-piece design here isn't as bad as long as there is a bearing inside the motor tower. All right. I hope that has answered some questions. What up, real deal? If you just made it in, you're really gonna want to watch this from the beginning. There's a lot of good information here. I actually talked about you and Michael from Paragon in this as well. Honestly, I think this is something that you guys need to start doing on your motors that you have made. Both you and Michael are having motors custom done. And I think you guys should, what's it called? I think you guys should actually start putting this into practice on the motors that you guys have made. So I want to talk a little about shimming now. We only have a little bit. No, you know what? I'm gonna save the shimming for another video. Maybe I'll do that next week or later on this week. You know what I mean? Don't worry, Takala or Titikal, Hala. I'm sorry if I'm saying your name wrong. Alec, is that you? All right. Well, it doesn't matter if you missed the first 45 minutes. This one's going to be, it's going to be saved to the YouTube, so you can actually watch it later if you want to. Yeah, real deal. I know you're always looking to improve your stuff and make stuff better. And if, any advice I can give, any stuff we can talk about, there's a whole bunch of stuff that we like talking about around here. So, and I'm available anytime. You have my number. You can get a hold of me. So SJSC, I think it was asking about when my shims were going to be available. I'm looking at doing some shims. As you guys can see, some of you guys samples out to some of you guys. But this is my design. I'm also going to have them laser engraved with the numbers on them. Everything I do is going to be in 6mm. The reason why I have the holes in the shims, which nobody else has, is because there's so little grease that gets put on these gears. Now, like the Siege Tech stuff, they have this little groove. And that's what that little groove is for, right inside that axle, is for grease. So that you can retain just that little bit more of a grease. Just that little bit more of grease inside that axle. Because, most of the time these things run for however long they can run until they just break. You know what I mean? Like any gear set, they just run until they break or wear out or cause excessive wear and stuff like that, because most people don't have a regular maintenance program. So these little tiny holes, now on stuff like this where it's a 0.2mm, it's not going to hold very much, but those little tiny holes inside of there will actually hold just that little bit of fractional bit more of grease inside of the shim. And as the shims rotate, especially when they rotate against themselves or they rotate against the gear or anything like that, it's not a capillary action, but it's kind of like a wiping motion. It'll pull out a little bit out of one hole, put a little bit in another hole, and as it goes around, Jesus, that's just, focus is just going crazy on that right now. So it'll rotate them around, and it'll help keep a little bit more grease, and it'll help keep a little bit more lubrication in the cycle and allow it to be used in the cycle. So that's why the holes are there. Started with 3. I might put a little bit more. The shims are also going to have the size thickness engraved on them. I'm only going to be doing 6mm shims. I'm not going to do anything larger because You don't need anything larger. You don't, I don't know if I put that on the wrong one. You don't need, I think I did actually. I think that's supposed to be on the, I think that's supposed to be on this one. Either way, I guess I'm going to have to go back through and reshim this gearbox shell, right? We're just going to bat 1,000 on that, and I'll just go ahead and reshim the gearbox shell. What's it called? I've gotten a few more questions here. What is it? Yeah, look and produce, Alec. The discussions of oh God, yes, yeah. That's definitely another thing I want to really want to talk about. SJSC is the optical sensors that a lot of these MOSFET companies are using now, and the fact that like it's, and I've noticed it especially with the Titans, because the Titans were super picky about it, about people not putting enough lubrication, if any, side of a gearbox, and just letting it run. And then your gears are going to go up on the axles because they're running, you know, the focal point of how that stuff runs is so tiny. And it's just going to have that issue. Yeah, and then right, another moly versus silicone grease, although that's something that we can touch on in the trends of lack of lubricant in gearboxes as well. You can start talking about that same stuff. But yeah, I mean that's for now, that's pretty much for what we can talk about for this. I don't know how I did another 20 minutes without actually talking about any other stuff. Well, I got wrapped up at 40 after, and I've done another, 15, 20 minutes on the same subject for crazy stuff. But hopefully you guys, okay, Alec, so you're kind of correct there. But the problem with that, with doing that, in using a large shim to help give support and help eliminate the axial force, is because it is as soon as you start doing that, you're actually adding the friction that you would be eliminating because of you're actually adding the friction you would eliminate by using bearings instead of bushings. And if you do that, then you might as well just go ahead and use bushings, because you're adding that friction in that you were trying to eliminate the other stuff. And I've seen it. I've seen like 7 mil and 8 mil bushings or bearings, and they've used the 8 millimeter wide shims on that point. And yeah, you see where the shim is actually pushed against the side of the bearing. Sorry, I don't use bearings, so I'm used to using bushings. That's what I talk about. And it can improve the lifespan, because you have that support of the piece on there. And granted, it's not as much friction as you would have in a bushing, because it's only that outside edge that it's actually touching. But yeah, it would improve it a little bit. But yeah, you wouldn't have as much friction. But, and this is something else that I wanted to talk about too, is and man, I really need to do another live video so we could talk about some of this other stuff. But I mean, I don't care. I'll go talk on all morning. I give a fuck. Yeah, this is gonna end up being like a 2-hour video now. The everybody loves, a lot of people just love doing bearings, because they go, okay, it's going to give you the higher rate of fire, it's going to give you the higher this, it's going to give you the higher that. but it really, I do believe there's less than a 10 to 15%. I think it's less than 10%. I'm pretty sure it's less than 10%. There was a discussion on this on airsoft mechanics way back in the day. I can't find the discussion because airsoft mechanics is shut down. But from what I know, bearings for our size stuff really only gave you like a 10% increase in rate of fire. And honestly, compared to my bushings, they're not going to give you any increase on the lifespan of the bearing or bushing. You know what I mean? As long as a bushing is properly a good quality bushing, not like the G&G or APS or any of those bushings that use the soft brass, bronze type material. The closest thing would be the modified sintered the modified tempered ones, which are a little harder, but they're not super, super hard. Retro arms bushings are decent. I've even found, honestly, VFC bushings are decent as long as they're properly lubricated. I have some in some builds that I've done that they were okay. Um, oh, Danny, I still need to send you some samples of my stuff so you can see what good bushings actually really look like. And consistency. My stuff is consistent. Um, I know I still need to send it. But you got to hit me up so I can send you, or so you can send me your information and I can actually get off my ass and send these out. Um, so, uh, what's it called? What were we talking about? Hold on. What was I looking at? Oh yeah. So, I do believe it was only a like 10% increase of rate of fire. And honestly, if you're running at uh what's it called? If you're running at 30 RPS, you know what I mean? You get 10%. So you get 33 RPS. A 3 RPS, you're not even going to really, honestly, you're not going to notice it. At the rate of fires that you're doing, this gearbox is the Gate Eon gearbox. SJASC actually answered the question for you. You just missed it. But that's the Gate Eon gearbox shell. It seems okay. I like it. I still haven't run it yet. So I still got to do that. I still got to run it. I haven't run it yet. So I still can't give you a huge opinion on it because I haven't actually put it through its paces. It does have some nice features that I like. I will try and touch on that stuff later. But, yeah, so the, bearings only give you a certain amount, of increase in rate of fire. They don't give you any increase over my bushings in lifespan. Although there are people that have run it 50, 60, 70,000 rounds with bearings and they run it real well. And that's perfectly fine. You know what I mean? Run it all you want. If they work, they work. If they work in the platform that you have, then they work in the platform that you have. So, but for me, it's still bushings because, I have bushings and guns that have been in there 10 years and they still have the same bushings and they still look almost new. You know what I mean? The only thing that is now they're a little shinier. Like that one here, you can see it's a little shinier. And this is just from it being rubbed or ran dry, and it just kind of scuffs up that surface just a little bit. But like I can run my nail over that, I can't even feel it. There's no difference in the actual surface of that piece. So, I can't think I can't really think of anything else right now. Shimming, I want to talk about at a later date. Maybe at the same time we talk about shimming, we'll talk about lubrication, and the types of lubrication. I mean, personally, I use this stuff. Currently, I use this stuff and a combination of that stuff and the Tech T gun salve for compression parts. I do not use that stuff on my gears. On my gears, I use a moly disulfide fortified high temp grease. This one is made by, I want to say Timken, same company that makes Timken bearings. And I bought it because it's super tacky. It's super tacky. It sticks. I started using that several years ago, and I have, if you look back at some of my other stuff over there, or some of the stuff on my Instagram, I have gears that still look like they're brand new. One of the ones that I was really impressed at was the saw, the Stoner 96 that I just did. And its gears still look brand new, or pretty close to brand new. They've pretty much just worn off the oxide coating. Actually, I still have, oh, no, that one's greased. I'm not going to pull it. I still have it apart right now because of an electrical issue. But the gears are greased, so I can't really show you how good they look. But if you look on my Instagram, you can actually see that there's several pictures of them on my Instagram. And this thing was used as a saw for 6 years. It went to almost every American Milsim event. It was used by I was built for Cody at Whiskey One Airsoft. And then my buddy, one of my teammates, bought it 2 years ago. And it has ran at 7 or 8 American Milsim events, heavily used as a saw, like 10,000 rounds every event. And it's the black oxide is worn off on certain parts of the gears, and that's it. Like, other than that, there's nowhere. This thing runs like a champ. So other than that, I don't think I have anything to say right now. We will hopefully you guys will look forward to seeing we'll look at shimming, and that's mainly on shim placement and shimming, and it'll be a general thing for shipping. I'll talk more about my shims and the size I use and the reason why I like using them, and stuff like that. But at this point right now, I feel like I'm just rambling. I'm not really talking about anything, so I'm going to go ahead and shut this down. And hopefully you guys have some good information in there, and hopefully this thing gets shared around a bit and everybody can check it out. All right, you guys have a nice day. Thanks for watching. I'm sure I'll be hearing from some of you guys later. All right, bye.